with everyone settled and everything being quiet again, we have the third and final session or talk of the session on networking consensus. Our next speaker is Master of Science in Communication Engineering from TUM, is now a PhD candidate at the Chair of Network Architectures and Services, and is mainly focusing on applied and threshold cryptography, trusted execution environments, as well as distributed systems, resilience, and robustness. Our next speaker is Filip Rezabek, and he will talk about METHODA, the framework for distributed systems evaluation. So a warm round of applause for Filip.
Thank you very much, Richard, for the introduction. Without further ado, let's get started. So overall, what I want to talk about when it comes to METHODA is like what open challenges actually do we try to solve with our framework, what are the considered scenarios in our setting, provide also our methodological approach, design decisions, and also try to provide actually some validation results that our approach for evaluating large-scale system is valid. And of course, since we are in the research framework, we're always happy to hear your ideas or we can work on in the future when it comes to the distributed layer systems. So the general motivation and aspect that we want to solve is when it comes to blockchains, we know that they are running out there in a global distributed setting where we have usually more than hundreds of physical nodes, even thousands. And how are we actually able to bring this setting when it comes to large-scale systems into our local environment? The reason we want to do it is to be able to actually evaluate the systems when it comes to their many configuration parameters, the various types of consensus mechanisms, and also actually extend the capabilities of site setting in our local space. So definitely when it comes to that, we have faced many challenges that I will try to share with you. And what we definitely also see that there are so many different building blocks that actually can be used inside of the blockchain that we will be also covering throughout the run of the conference, that definitely we see that the development and the restoration never stops, so our framework should be able to actually incorporate such type of changes in the long term as well. So providing some additional aspects of course what we are interested in when it comes to choosing the corresponding layer 1 of our ecosystem is how performant it is, like how many transactions per second the system can handle, what is the latency when it comes to the usability, when I submit a transaction, how fast actually is this transaction being finalized, how fast is the propagation between the individual pieces in the system, and many other stuff. We of course have also other aspects of technology that have to be discussed in the context of blockchain that are maybe not as relevant now, but might be relevant in the future, and are maybe active part of research. So for that we are talking about the use cases when it comes to mempools, private compute on permission blockchains, for which we can use various type of solutions using TEEs or multi-party computation. Then we are also interested in the rollups when it comes to their scenario approach when it comes to scalability, and of course look into the aspects of privacy as peer-to-peer solutions. The last one, that of course we know that each blockchain system has its own type of requirements when it comes to the hardware, and has its own parameters and metrics we are interested in evaluating. So when it comes to all of these aspects, we want to make sure that our framework that we use to evaluate such type of solution is actually able to support all of these individual scenarios. And more importantly, when we actually want to deploy such stuff locally, we are interested in doing so in a reproducible fashion, which means that not only us, but also other peers in the globe, let's say, are able to reproduce our results to reach hopefully the same conclusions that we did. Should be able to compare different architectures. For example, depending on what is the type of ZK or cryptographic primitive you choose, you should be able to assess its security properties, but also see how does this impact the overall implication of such on the system, and also try to provide this maybe something like a call for action, not only from our side but to the industry as well. Try to actually provide some form of a common ground for evaluation that actually can be later maybe shared with other parties, because as we know there are many L1 solutions that are evaluating their systems, or different L2 solutions that are also evaluating their system in a certain way. Basically found a common ground, and the advantage of using and running such stuff in a private deployment is of course that there is no external noise, and we are basically getting the pure performance of the system in such a way. And therefore we gonna, as actually a research group, are quite heavily pushing for the aspect of deploying such stuff in a controlled environment, where we of course try to emulate the realistic deployments that are running out there. So some of the scenarios we are considering when it comes to evaluations, of course, we are investigating some aspects of having different consensus and having different properties. So how does such stuff compare when it comes to, for example, safety, liveness, and others? We are also considering the life cycle of from the user perspective when it comes to, for example, sending a transaction that is later on from it combined into a bulk, and also how does additional messages propagate, for example, loads in the system, how much demand actually does it have and strain on the individual peers in the network. We also want to understand the overhead on each peer and the expected hardware specification to achieve the optimal performance of the system in the local view, but also in the global setting. We're also interested, something that actually we are working with colleagues when it comes to the peer-to-peer network structure and see basically how centralized or decentralized the underlying network is. And consider many other aspects as well when it comes to some future use cases relying on threshold cryptography, multi-party computation, or zero-knowledge proofs. And of course, all of this stuff is actually running on some infrastructure. So how actually can we consider and evaluate the impact of the infrastructure on the information in the upper stack? For that, we also have this overview figure where basically the infrastructure, of course, is some of the fundamental aspect of the deployment we have to consider. And in general, we are of course building on top of the internet infrastructure because we know that when it comes to blockchains, usually we have some form of overlay that is used to exchange the messages among the peers, but itself is building on top of the internet itself when it comes to the provided guarantees. And we are interested basically how the aspects of the stack, especially the blockchain stack when it comes to data layer, network layer, consensus layer, execution layer, and of course the application layer can nicely interact with each other and provide functioning aspects of the chain itself. In order to be able to actually evaluate such a system, we are focusing on two types of deployment strategies. So we are mainly focusing on the local deployment, but also support cloud. So meaning if you want to, for example, evaluate Ethereum 2.0 in a private setting, we actually are able to deploy it in our local environment and actually also do the same stuff of deployment inside of the cloud as well. When it comes to experiment design, we have to also, of course, understand what we want to measure and evaluate. So for that, we are definitely spending a lot of time on assessing and doing the theoretical evaluation of the different systems to design the experiments properly. For that, we are also considering the aspects of black box versus white box testing, where especially when it comes to the blockchain space, we are more focusing on the black box testing, meaning we just evaluate the performance of the system externally. Because if you, for example, look at Ethereum now and 1 year ago and how many changes and updates there were, it will be very hard to stick to the white box testing because the software keeps developing very fast. And we will kind of have to have our own fork basically of all of the dependencies, which is something that we don't want because we will maybe with that sacrifice some aspect of realism and the latest state-of-the-art updates of the corresponding clients. And when it comes to doing evaluation, we are of course interested in considering as many metrics as possible: throughput, latencies, CPU, RAM, I/O, just to name a few. And when it comes to the modification and tweaking of the parameters, we of course want to consider the size of the deployment, various thresholds, runtime configuration, and many others. So kind of combining all of these aspects together, when it comes to the motivation of what we want to do, how we want to do it, we have defined the overall aspect into our framework called METHODA. That is basically taking certain types of inputs that are defining the experiments. When it comes to the data sources and the network we want to have. An example, we want to deploy Ethereum with 100 physical peers, where each of the peers will have 1,000 data running on top of it. This will be basically defined as the input to our framework. Then the framework will deploy this as a system under the test. So basically all of the individual parties will be started accordingly. It will be combining the validators. We can combine also different types of clients and many other stuff depending on the scenario. And then we will let it run. And we will be modifying the parameters along the way to basically collect the valuable insights that will be stored as a part of the measurements artifact. And later on we will do evaluations of the individual insights to basically make sure that we understand and see how the experiment design basically is matching the expected findings or not. Many times we also see basically that our design was correct, but the findings are very different than to be expected initially. It's also interesting to see the synergies between the system properties in theory and also actually in practice in that sense. With respect to time, I will try to cover some few scenarios that actually we are currently investigated. One of the main focuses on trusted execution environments. Maybe a quick hands up, who knows what are trusted execution environments? Quite a crowd, nice, that's good to hear. Some aspects also that we are looking into is the domain of threshold cryptography, and also we will briefly mention on MEV behavior on Overground. and like just motivational experiments we have dived into, but it's not limited to. The framework basically was also used for some other aspects. We were looking into Ethereum when it comes to the understanding of the latencies and the TPS of the system. We are also now looking into the aspects of and synergies between deployments of full-fledged L2s in our local deployment together with the underlying L1. We are also looking into the peer-to-peer network and other types of stuff. But overall, the experiments that I'll be showing now are basically showcasing the versatility and the capabilities of the system in order to be able to collect such type of insights. So just firstly, briefly looking into the aspects of TEs. For those that know, TE, maybe these data are not too surprising because the main advantage actually of the execution environments as they are is the less impact they have on the processes running inside of TEs. Especially here I'm looking into the PM-based TEs, meaning that actually not only certain operations are run inside of a TE, but actually the whole client is deployed inside of a TE. What does it mean? That basically all of the I/O and CPU and RAM overhead basically will be coming by the TE is something that we try to visualize in these figures. Namely, we are comparing a baseline that basically just like is a bare metal deployment, then also running a Docker, like a container solution that is already having some limited hardware capabilities, constraint basically when it comes to the amount of resources it's given by the system. Then we compare it to a Kata container. So for those that are not familiar with Kata containers, it's again, I would say a lightweight virtual machine solution that basically is more lightweight than VM, but at the same time it's not fully like a Docker container in a simple terms. And the important part why we choose Kata is because actually Kata containers can run also in the part of the full-fledged virtualized execution enclave. And we have two types of experiments. So we have firstly evaluation of compute-bound experiments, and then we have on the right side the memory-bound experiments. So just briefly what we see on the X and Y axis. So on the Y axis we see the the execution duration. On the X axis we see the dataset size. And as we see, what is something that we are interested in seeing is that the TE is following quite closely the baseline, basically. So it means that the overhead caused by TE is rather small. And the same basically we see on the right figure, where we are having different type of parameters. We are modifying the matrix dimension and the number of floating point operations where a secondary system can handle. And again, we see that the TE is having worse performance, but the impact is not so significant, which I think is basically making mainly focusing on the aspect of feasibility of such solutions to be used in practice. Second one, just briefly providing is aspects of the impact of threshold signature schemes and the individual operations. So this is, I would say, more like a micro benchmark, so that we evaluate the individual operations within a complex protocol. Especially this is focusing on the distributed key generation and also later on the partial signing and others. And we are, through that, basically able to identify where we spend most of the time. This also helps us to determine the scalability of such solutions. And lastly, maybe more interesting for some of you is the aspect of evaluation of MEV in this context on first come first serves on blockchain named Algorand, where for those that are familiar with the MEV game a little bit more, you know that on Ethereum mainly the transactions are structured based on the amount of fee basically you pay, whereas on Algorand they are structured based on their arrival time. So of course, having a good connectivity to the proposals is very important. We basically try to evaluate such type of scenarios in our testbed to basically see that our theoretical assumptions are matching actually the possible behavior in a large-scale setting. And for that, we have basically devised different type of scenarios with different level of complexities to ensure that we are able to understand such type of behavior and later on investigate it possibly also on the mainnet, which is our ongoing work with some of my colleagues. So overall, what I wanted to present is basically a framework that is able to provide granular control and is able to collect diverse insights from various types of deployments. We are also able to accommodate for large-scale deployments, which is, I think, very interesting, especially when it comes to the blockchain setting. We've also identified several open challenges, so definitely we see a lot of variety when it comes to the different L1s, which of course can later on impact the findings. And definitely what we would like to call for action, we also had a discussion yesterday with some of the other researchers, is maybe look together into definition as it's happening in some other fields to identify a set of workloads basically that you can evaluate in different type of layer ones and make sure that basically we are evaluating the system under same type of workloads to basically see and have fair type of findings. For those, maybe some of you already know it from the AI case, when you have certain type of image recognition stuff, you basically are getting fixed benchmarks to see how your algorithm compares to. And it'll be interesting to have something like that similar in the blockchain space when it comes to defining types of workloads that are relevant for the users themselves. And overall, we see it like a stepping stone to basically be able to achieve holistic view of interactions in the different layers of the stack. It will basically help us to develop a new generation of core developers to be able to handle such type of complexity as we see in the large-scale systems. We also cannot investigate or are interested in different type of use. So of course, one aspect is the private compute on public blockchains. Definitely something very interesting for our future research. We also are investigating the use cases of building blocks when it comes to the deep in, and something actually someone after me will be talking about is the aspect of simulation on such scales. So we'll be interested to also discuss aspects and comparisons of simulation versus emulation when it comes to the P2P network or also component use itself. So overall, I think there is quite a lot of stuff going on when it comes to research opportunities and synergies. I'll be happy to find out more. With that, I would like to thank you, and I'm happy to take one or two questions.
Thank you, Philip. So there we have a question.
Yeah.
Hi. So this seems like a rather complex piece of software you have there, right?
Yeah.
So to interact with all the different protocols and layers and so on and so on. So I'm wondering, what is your choice of programming language you choose?
Yeah.
for it?
Yeah, thank you very much for the question. So the framework itself is written in Ansible. So basically that way it's allowing us quite a lot of versatility when it comes to deployment of such systems. And of course we are also interacting we are able to interact with any third-party software. So meaning, for example, we are also writing our own code when it comes to the stuff we want to evaluate, but we are also able to take, for example, full-fledged Ethereum execution and consensus client and deploy it in our framework in such a way as well, so that we are basically able to evaluate, I would say, any third-party software under condition. Just basically have to define the interfaces properly and make sure that we are able to deploy it in the local setting. So that way, using Ansible, basically we have quite a lot of versatility to basically be able to deploy any type of underlying software in such a way.
And then you interact on RPC level?
Exactly, yeah. So basically we call it like different services, so different applications, for example. So we define one service being the execution client, consensus clients, they have to communicate with each other. Then we also define clients that basically are interacting with those and are generating transactions, for example. And we are having probes in the different parts of the network to basically make sure that we are collecting the artifact that we are interested in.
And you're also collecting Prometheus?
Sorry?
You collecting Prometheus data from
We can do it as well, yeah. So currently we don't do it, but definitely something with respect to we could deploy Prometheus basically for Grafana, right? Or for example, we could do it, but since we usually focus on short-term experiments, Prometheus, for example, will be fit enough because it's only doing snapshotting. So we are also having some additional tooling to have more granular information with respect to the actual CPU and RAM usage during the runtime. Yeah, but it will be possible to also use something like Prometheus. Yeah.
I'm wondering about the. I can just speak loud, no problem.
Yeah,
I wonder what are your conclusions about the MEV experiment on our end, and like what is that difference from MEV in other chains, and yeah, basically what are your conclusions? I don't think you have the time to explain it. I'm really curious.
Definitely, I will be happy to try to answer to the best of my knowledge. So I was working mainly with Burak, we'll be asking around later on as well. So I think the findings basically are that it's really behaving as first come first serve. And currently in the paper we have written together with Burak, we're mainly focusing on the aspects of understanding the fundamental peer-to-peer layer and look into the mainnet when it comes to actually seeing how much MEV is being extracted. This is basically the first step. And the second step, what we are currently working on is try to see, okay, we know how it behaves. Can we actually try to map it to the real world as well? So basically try to see CFS is being played on the mainnet to basically see, okay, are we actually able to identify positions that are more convenient or less convenient for certain types of MEV extractions in the fund as well. So basically it will be really to certain type of data centers where you have proposals with the deep pockets that have a higher likelihood of being selected to propose the next box. So this will be basically very interesting, but we hope that the findings we will get also applicable to other chains that are basically FCFS. And especially I think this will be very interesting for L2s and Ethereum that currently are mainly also first come first served basis. So it will be, I think, interesting how this affect the overall MEV game.
Thank you.
All right. If we don't have any further questions.
There is one quick question.
Yes.
Just a quick one, please.
Yes. What's the so this is basically a tool for design analysis. What's the main advantage of using TEGs if it's not really in a production critical environment?
So the aspect of TEGs is not to, let's say, protect our, I mean, theoretically it could be an interesting scenario when it comes to, for example, deploying confidential code from parties, third parties, like partners that we have, and they want to run their code in our environment. We are able to assess it by arguing that we run it instead of a TE. It would be a very interesting use case that we didn't investigate, but it's rather the aspect of creating new use cases, for example, in the Web3 space, when it comes to encrypted mempools or MEV prevention techniques that will be relying on TE, and we want to assess how such type of scenarios will be actually impacting the mainnet when such solutions will be deployed. So it's basically rather part of the design space, so we are able to evaluate its later on full-fledged deployment on the mainnet, for example, of a certain chain. Yeah.
All right, then thank you, speaker. Very much.
Thank you.